Hi, this is Dr. Green. I wanted to do an example of a one-way ANOVA with Post Hoc tests and then also with the APA summary. So they did a really nice example in the Blackboard presentation of an ANOVA and explaining what it is and why it works, but they didn't do the Post Hoc test and they didn't do the APA summary. So I wanted to go through an example and do those Post Hoc tests with you, because the ANOVA will tell you at least two of your means differ, but it won't tell you which ones. It's the Post Hoc test that will tell you which ones differ and how they differ. So which ones are greater and which ones are less. Blackboard. So in this example here, we want to determine if there is a difference in GPA between the classes. So we did a random sample of 4 freshmen, 4 sophomores, 4 juniors, and 4 seniors, and those represent 4 different populations. Each population will have a mean GPA that might be different. What we want to decide is, are the means different, the 4 means, or are they all the same? Actually, it would be, are at least 2 of the means different, or are they all the same? Because the opposite of all the same is, well, 2 or more could be different. They don't all have to be different statistically, but 2 or more. So the question is here was there a difference in GPA among the groups? So to do this, we have to use the Anova test. So in your data, you want to click the Data tab, and then click on Data Analysis, and then right up at the top here you will see ANOVA Single Factor. So you're going to click on that one, click OK. Our input range, we're just going to drag across everything here. And we are using columns. We did put our labels in the first row, and for our output range here, I am going to select this cell just to the right. That's the upper left-hand corner of our output table. So click OK. And there's our output table. And we see our means here. For the freshmen, mean GPA was 2.6, sophomores 2.62, juniors 3.25, and seniors are slacking off 1.95. So it looks like juniors have the highest GPA on average and seniors have the smallest, but we don't know for sure unless we know it's statistically significant. That's what the ANOVA tells us. And we want to look at the p-value right here, and that p-value we see is less than 0.05, so that means at least 2 of the population means are different. These are sample means here, but we're asking questions about the population mean. So this first question, was there a difference? Yes, there was. And the reason was that our p-value was less than 0.05. In fact, it was 0.0096, so that's actually less than 0.01. And now we want to know who had the highest GPA. So this Anova test, that p-value right there is telling us that 2 of the means are different, but it doesn't tell us which ones are different. It doesn't tell us how they differ. So we need to do some further investigating to figure that out. And the further investigating we need to do is a t-test. So I'm going to go ahead and conduct a t-test. Here, it looks like from the averages here that the juniors were the highest. So we want to compare the juniors to the next highest, which were the sophomores, and see if the juniors' GPA was statistically higher than the sophomores. If it was, then it'll be statistically higher than the freshmen and higher than the seniors. So let's go back to our Data tab here, click on Data Analysis, and then we're going to go down to the bottom to our t-tests. Now these are not paired t-tests, it's not pre and post, they're independent. These are 4 independent groups. So we're going to do the 2 sample assuming equal variances. I'm going to click OK. First variable range here, we're going to do, let's see, we thought that our juniors were the highest, so we're testing juniors against the next highest here were the sophomores. So we're going to test, so let's make sure we've got juniors in here for variable 1. And then the next highest were the sophomores. That's variable 2. Hypothesized mean difference is 0. We're going to click labels because we included labels in the first row. 0.05 is our test value, our alpha value we're testing against. And our output range, why don't we just put the upper left corner of the table just below the ANOVA. I'm going to click OK. There we go. And click OK. Something went wrong here. There we go. I think we're okay now. A16, yeah. Okay. So here's our first t-test. And we're testing to see if they're greater, if the junior's GPA is greater. So that is a one-tailed t-test here. So if we widen this out here, our p-value one-tail is right here, 0.047. And we see that that is less than 0.05. So that means that there is a statistically significant difference. So in answering this second question, who had the highest GPA? That is going to be juniors. And then how did the seniors compare to the others? So that's our last question. And yours are asked how the control compares to others. So here our seniors had the lowest average GPA. These are the sample GPAs here. So they had the lowest sample GPA, so it looks like the seniors are lower than everyone else. So what we're going to do, t-test can only compare two groups at a time. We'll test the seniors against the freshmen, which are the next lower group. If they are significantly lower than the freshmen, then they're also going to be lower than the sophomores and the juniors, and they'll be the lowest group overall. So we're going to conduct another t-test here. So I'm going to go to the Data tab, Data Analysis. This is selected from last time, t-test to sample, assuming equal variances. That's independent t-test. Click OK. We'll want to select new ranges here. So it's got the old ranges in there. So let's get rid of those. So our variable 1 range, we're testing the seniors. And we are going to test that against the freshmen, were the next lowest average there. We see the 2.6 compared to the 1.95. And hypothesized mean difference is still 0. We're still using labels. And for our output, why don't we click just to the right of our last table. So right here. Click OK. And then what we see is that seniors compared to freshmen, senior mean GPA for the sample was 1.95, the freshman was 2.6, and we're testing to see if the seniors are less than the freshmen. That's a one-sided test. Here's our T statistic, and what we're really interested in here is our p-value. We see our p-value is 0.035. What's important about that is that it's less than 0.05. That means the difference is statistically significant. So how did the seniors compare to the others? They were the lowest. So now we want to summarize this all in APA format. Okay, all of our results here. We answered the 3 questions from the output. You want to include all 3 output tables, the ANOVA and the 2 t-tests. And then you want to do an APA summary. And so your APA summary should sound something like this. One-way Anova test was run to determine if there was a significant difference in GPA between the classes. Let's go ahead and tighten that up a little bit so it's all in the same window. And the results of the test indicated that there was a statistically significant difference in GPA. Okay, that is from the Anova test. And then APA indicates that you should specify the F statistic and the p-value. So our F statistic in the Anova is right here. That's the 6.02. And they also like you to include the degrees of freedom for between groups and the degrees of freedom total. So the 3 and the 15 and the 6.02. And that is this information here. So the 3, the 15, and the 6.02. So you want to tell what the value of the test statistic was. And then our p-value was 0.009, which is less than 0.01. So again, that's this p-value right here for the ANOVA. It's the ANOVA p-value. Okay, so that tells that at least two means were not equal. Okay, that's what that shows so far. And then we perform these what are called Post Hoc T-Tests. Okay, we wanted to see how they differ. And they showed that the juniors had the highest GPA. We want to list the T statistic and the p-value. Okay, so that was right here in this first t-table. Our t-value was 1.98 there. Our degrees of freedom were 6. So that is this 6 and this 1.98. Our p-value was 0.047. So you'd say p less than 0.05 or 0.048. That's pretty close to 0.05. And then we showed that the seniors here had the lowest GPA. And we want to indicate their t-value also and their p-value. So if we go up to the t-test here for the seniors, that's the second t-test, we see that that test statistic was negative 2.197, which if you round that, it's negative 2.2. Degrees of freedom were still 6, that's right here. So you put the degrees of freedom in parentheses. This means the t statistic with 6 degrees of freedom was negative 2.2. And then our p-value, 0.035, is less than 0.05. In fact, it's less than 0.04. So that's your APA summary. That includes both your statistical conclusion and your practical significance. You know, what was lowest, what was highest, and which were different. So remember to include your summary. It should be similar to that.